Yes, thank you I also would like to welcome you to this talk about the use of OpenStreetMap in journey planning. What are we going to talk about in the next 20 minutes? First of all, I want to introduce ourselves and what we do. And then I want to show you what we do with geographic data and why we are interested in using OpenStreetMap. And then to get things a little bit more concrete, I want to explain a little bit more detailed on the example of railway routing, how things work. After that, I want to already give some thoughts for the discussion, maybe afterwards, about the implications, and also a quick outlook on what's next for us. So, who is MDV or Mentz Datenverarbeitung? I'm sure maybe some of you already came across our company or the name of our company in the talk lists, but I'm pretty sure most of you have already used our products. For example, if you came to the venue of this conference by public transport, you might have checked the best possibilities on the website of the local transport authority, the KVV, and then you use their journey planner, and this is one of our products. So what we are a service provider for public transport authorities and operators. We provide the data management and journey planning systems that they use to work with the data. So we provide the means that we don't have any data by ourselves, we just provide the means to work with the data. And very important to us and the systems, geographic data has become much more and more important since we started. So let me, first I want to also show you that we are quite an international company, so we have clients all over the world. And this is also another reason why OpenStreetMap is so interesting to us, because it's a global project and database. So just very brief and short, how does it work? On the one hand, we have a data management system, which we call the journey planning system. It's comprised of many different components, like the classic scheduling, contract management, duty scheduling, vehicle scheduling, and also one of these components is a GIS. And what we do with geographic data, we import it into our in-house GIS. We have an own format in which the data is transformed so that we can use it then in our system. And this journey planning system then is used to provide the output for the journey planner. These are the tools that the end users use, like the web tools. We have mobile applications, but we still also have print products, of course. So why do we need geographic data? Maybe the simplest example is just what I mentioned before, a journey planner on the web, an online journey planner. This is a screenshot from our journey planner in Sydney. You want to display route options. You want to calculate distances. You want to have different time route options with the different times that you need for the travel. So this is maybe a classic example of why we need the geographic data in our system. But of course, we also want to generate maps. If you walk into a station, very often you have a network plan there, and these network plans are customer specific. So each customer has their own requirements and their own design, and we generate these maps for them. This, for example, this slide shows an example on which we did with OpenStreetMap data for a showcase for one of our customers. So this is all OpenStreetMap data that you see there with the specific style that they required. What else? Navigation, of course. You want to have address navigation, so you want to know how to get to your stop. Of course, you need geographic data again. This is an example from one of our mobile applications where you really have turn-by-turn navigation on the geographic data that is in the system of this specific client. But when we are already talking about navigation, this is the thing we are really interested at the moment. It's indoor navigation. So we really want to use geographic data to, for example, calculate interchange paths inside stations or in between stations to really give a very detailed navigation inside a station. This is so an example from one of our OpenStreetMap test systems. You can see really that there is the path really detailed from the metro station to the regional train connection. So, and we did a lot of work recently on mapping, indoor mapping in Germany particularly. But of course we also have internal use for the data. We have to calculate statistics. We need to know how many kilometers the vehicles run. The operator needs to know how much gas he needs, what the costs are. We have official data for governmental purposes. So there's also a lot of things going on here where really accurate geographic data is used and needed. So why OpenStreetMap? Why are we interested? I'm sure I don't have to convince you in here from OpenStreetMap, but let me just show you this slide. On the one hand, you have the GIS data that that is in use right now very often, and on the other slide, you have the same street crossing in OpenStreetMap. So this is what it looks like after the data is imported into our GIS format, and you can see how rich the difference is obvious, I would say. But there are also other important factors for public transport providers that use geographic data. One of them, of course, is no license cost. Commercial geographic data is very expensive, so this is an important issue for them. But also, open data license is becoming a really important thing, because open data in general and open governmental data, more in particular, is now very promoted and very important for the decision makers. So here the open data license supports this idea, and therefore there's a strong interest to move from this commercial products to an open data license. Then more a technical argument for OpenStreetMap, you have instant data updates. So until now, the update cycles for geographic data were rather long. So if there was a problem in the data and the problem was reported and then fixed, and until it got back to the user that was using the data, it could take a very long time. With OpenStreetMap, the user can fix the problem himself and update the data set that he's using, import a new data set, and he has it in really very short time cycle. Another thing that also maybe goes close with the initiatives around open data licenses and open governmental data is investing in public data. A lot of public transport is substituted or funded by the public, so there's a strong interest, of course, also to rather invest in public data than in commercial products. And maybe last but not least, transnational data. With commercial products, it's difficult or sometimes not possible to get transnational data. With OpenStreetMap, this is no problem. So let's move maybe to the example. I want to show you how things work, what we do, and also some of the issues we are facing and the problems. I chose railway routing because this is pretty straightforward, you would think, and actually it really works. This is a screenshot from our journey planning system, and it shows the connection from the high-speed connection from Frankfurt to Karlsruhe. This is the routing we are doing based on OpenStreetMap data, and you see it really works. It's good. We are using it, and we are quite happy with it. So when you look at railway routing, this is a pretty straightforward thing, one would say. You have the connection between two stations. They are connected by a rail track, and so the train can run only on the track, of course, so no shortcuts. It can't take shortcuts. You won't allow U-turns, and that's it. But then I've just mentioned here a few issues that we are facing that arise when you look at the attributing of the data and when you really try to make more sophisticated routing with your data set. So sometimes you have a rail direction in your data, or you have level information. You have different rail categories. For example, in tunnels you have subway rails, or you have the standard rails, and so on. So if we want to do routing, we have to somehow use these information to provide the best possibility, and the trick is to find the right combination of attributes that it works, because this is the attributes are very often not consistent. So, and also the use case is not consistent. Sometimes rail direction is very helpful, but here I also write that in subways we often have only one rail in the tunnels instead of two. And if there is a rail direction attribute on one of these tracks, then the routing will work only in one direction. So here we shouldn't use the rail direction, or we would have to fix the data, like mapping a second rail. So we have also different categories of rails. Sometimes they are there, sometimes they are not. Maybe the next example will show you why this is important, because trains are not allowed to take shortcuts. But like here, you can see here we have parallel tracks, or almost parallel tracks. One is the high-speed rail track, and the other is just the standard rail track that's going on the inside. And what our high-speed routing did at the beginning, it just went on the inside, sorry, which is highlighted with the red arrows, and not on the appropriate track on the outer, on the fast high-speed track. Similar problems we have, for example, with sidings, or so that the train is rather taking, the routing is taking the siding tracks, not the these designated standard tracks, or maybe there's tracks that are designated to freight traffic. So here we are really trying to figure out the best possibilities and still working on it to identify all these issues. Because sometimes the data is very complete and good, and sometimes we don't have this information, so we have to find a solution there as well. So what implications will this use of OpenStreetMap data by public transport providers have? I just tried to identify some of them. I mean, on the one hand, the operators will have to adapt to this flexible OpenStreetMap data model, which is a big challenge because until now the data was very regulated and very standardized. Another thing is to adapt to frequent GIS data imports, which until now didn't happen. So they were working for a very long time on the same GIS data set. And another very important thing is that also we faced is learn to interact with the community, with the OpenStreetMap community. There's a strong discussion culture, there are the talk lists, so the transport authorities and operators will have to respond and communicate and work with the community if they want to be successful in using the OpenStreetMap data. So this is also a thing that has to be addressed by them because they haven't had to do that until now. But I think I also tried to find some of the challenges and implications for the OpenStreetMap community, and I'm happy to discuss this afterwards and getting more input on this. I think OpenStreetMap will be exposed to more users that haven't heard of OpenStreetMap before. So this exclusive circle will probably be widened. And another very important thing is that if this data is really used by organizations and also for official purposes, the accuracy will have to be maintained. I mean, until now it's working very well, but it has to stay this way. Another issue that also has been frequently discussed on the talk list is the involvement of companies or organizations in general in OpenStreetMap. I know that there's been recently a discussion on the talk list, and I think this is just also another thing that will come up if more companies and organizations are going to use the data and also will be involved, not only taking the data, but really involving in the process and in the community. Then very important, data consistency, like I showed you, with all these different attributes, that sometimes they are there, sometimes they are not. So this is really a thing that also goes to the community, in my point of view, that there's still a lot of work to be done with the data. And which brings me also to the next point, that I think there will a lot of new tasks and challenges will arise for the mappers, because indoor mapping until now is still not very widespread. And if there's suddenly a use for this, I think there's also a new incentive to start to map these new areas of interest. So before I quit, I just want to show you what's next for us. On the technical side, we are really working at the moment on the indoor routing. This is our next really technical step. We are especially on mobile devices, so we really want to provide turn-by-turn navigation in buildings. And in the course of that, of course, implementation of services for passengers with special needs, so just the keyword with wheelchair, or if you have heavy luggage, which would be the best route for you, etc. The other big thing is, at least for us, that we are, in the next year, we have public transport providers really going live with OpenStreetMap data. So this is we will have several clients switching to OpenStreetMap, and more clients are discussing it at the moment. So yeah, I hope this all goes good, and would thank you for your attention and looking forward for your questions. Maybe you can just use mine.
Thank you. That was interesting. Do you give your clients like a choice to switch to OSM, or is it for them? Yeah, everyone gets.
This is a voluntary choice. They still can use. It's just another option they have to use different geographic data. So they are not. But yeah.
Yeah, as you know, we have several editors at OpenStreetMap, and one of them is called ID. And it is easy made for the beginners, but the bad side of the editor is that you can delete some wastes without being warning that there is a relation. How do you manage if relations are broken?
So, if I understood your question, so how do we deal with broken data if we use it in our system? We usually perform quality checks before we import a new data set into our GIS system. So we try to avoid as much of this as possible, to only import really data that is working. And if relations are broken, to fix that first, or address the user who broke it to fix it.
My question is, one thing which is really interesting is multimode routing, where you can
Sorry?
multimode routing,
yeah.
where you can ask for a route, including a bike and train, and don't have to decide which station you use. Do you know any projects working on that?
Yeah, I mean, we have several, like our router supports multimodal routing, and we have projects like in Vienna we had a really interesting project, not based on OpenStreetMap, but working on multimodal routing, for example. And
yeah, regarding the indoor mapping, do you gather some of the data by yourself? And if yes, by which means? Which special tools do you use?
yes, we do gather data by ourselves. We use JOSM for of course, and we really just have people working that are, we get data from the transport operators very often, information about the stations, for example, that we can use. Some of this is also by now publicly available. I think the KVV provided some, not the KVV, VRR, provided some data on their website for OpenStreetMap use as well. And yeah, and very often we also have to go into the station and really do it from scratch.
We have time for one last question, if somebody else.
My question is about the railway routing. I mean, why would we do that? I mean, in principle, is it just for passengers to visualize their journey, or could you, in principle, maybe in the future, construct timetables based on OpenStreetMap data? Because it seems that you really care about the fact that sometimes you have only one railway track instead of two. I mean, why is it that important?
Good question. I mean, at the moment, timetables are not constructed by the GIS data, but one very important thing is, for example, the distance covered. So there is, for example, commuters have often get refunds from the state. So, and this might be a variation of 1 kilometer, and this is the official data that the commuter is using to apply for such a funding. So this is really important that the data is accurate, because this would make a big difference if the data was longer or shorter. Just one example.
Okay, thank you, Thomas. And